Our proposed project 2E7 is large-scale anomaly detection from text and its application to medical records. Anomalous text detection refers to identification of irregular or unexpected text that significantly deviates from its context in comparison to the majority of normal or expected text. We have several meaningful applications of such detection. For example, in electronic health records, it is of great application value to identify unmatched diagnosis, record errors, rare drug effects, or extreme medical cases, resource abuses, etc. In biomedicine articles, or even more general scientific publications, it's an interesting and meaningful task to identify innovations, like new treatment of some disease, interdisciplinary discoveries, combination of previously relevant concepts or technologies, and so on. The anomalies from rich text are more interpretable and therefore helpful for decision making, because the algorithm could provide what text occurrences deviate from what normal pattern. This is of potential great use for industry applications. Now, big data brings both opportunities and challenges of anomalous text detection. First, any anomaly detection requires a well-established background. With large amount of data, the modeling and evaluation of background could be more effective and accurate, and therefore the anomaly detection could be more promising. But the challenge is the text data is high-dimensional and sparse, where many classic anomaly detection algorithms fail to apply. And what's more, previous algorithms do not take particular care of computation costs, and they will become infeasible to process a large amount of data. Another thing with industry need and relevance is online detection. Few current anomalous text detection methods consider time as a factor for their modeling. From an algorithmic perspective, the background is changing with time. A previous rare diagnosis may become common within a period of time because of an outbreak, and innovation at this moment may become common topic in the next year. So the anomalous text detection in the real world should be dynamic, or it's better to be dynamic. And from application perspective, a real-time detection of electronic health records anomalies and tiny feedback to the doctor might be a life concerning is the current goals and objectives of our proposed project. First, we will design basic models of anomalous text detection and conduct preliminary experiments to prove their effectiveness. After that, the next step is to scale up the basic model for large-scale processing. We have two potential approaches. One is to develop approximation algorithms to reduce time complexity. The second one is to find parallel algorithms to make better use of computational resources. After that, we would like to construct an online algorithm that dynamically updates the background distribution, and we will experiment on the capability of real-time anomaly detection. Finally, we will work with IAB members to evaluate the prototype using rich text EHR dataset or biomedicine article datasets and transfer them to the IAB members. One approach we currently have is to model the background by a probabilistic generative model. For example, in this previous research called PMAT, the background distribution is constructed by a variant of LDA, which stands for latent diffusion allocation, the classic topic modeling framework. The idea is very simple. The basic idea is simple. After the background distribution is established by this generative model, any text occurrence with small probability is anomalous. This PML model has been shown to be effective in comparison to two previous models under various metrics. And this model performs well with the sparse data. Although the current model cannot handle large-scale data and still have some limitations, like it's an offline processing algorithm, it shows the potential of this probabilistic approach. The next approach we will look into in this project is deep learning. As we all know, this is a very popular, powerful, and highly extendable modeling approach for many cutting-edge applications. For anomaly detection, the encoder-decoder network, or long-term source memory network, has been successfully applied to unsupervised and semi-supervised anomaly detection in computer vision. Recently, there are also researches on using deep learning for anomaly detection from time series or for network intrusion detection. The basic idea for deep learning or anomaly detection is that any data cannot be reconstructed by the network are treated as anomalies. This is an example of a very simple autoencoder where these red nodes are reconstructions. And for this simple LSTM network, this is the reconstructions. Deep learning has successful application in natural language processing. However, unfortunately, there's currently few application of deep learning to anomalous text detection. We would like to research over these challenges in this project. The deliverables of this project will be the models and algorithms for offline and online anomaly detection for large-scale rich text. And we will do scientific publications and elaborate on the technical details and experiment results. And of course, we will offer the prototype APIs with all the aforementioned. The impact of this project, the first one is that we will advance the frontier for this research anomalous text detection for large-scale online data processing. The second one, we will try to answer the question that whether deep learning techniques will be effective for anomaly detection from text. The third one is we will make comprehensive investigation into the meaningful application of applying anomalous text detection to electronic health records or to the biomedical articles to either detect aforementioned diagnosis errors or to detect innovations. This is the project duration and proposed budget, and thank you for listening to our proposal.